Direct and inverse variation. Direct variation is simply this. As one variable increases, the other variable increases. As one decreases, the other one decreases. It's kind of like this example right here. The more hours you work, the more money you should make. And so before we can do this example, let's look at some of the concepts involved with direct variation. When we say y varies directly as x, the equation that we're going to use is y equals k times x. And k is always a constant. So in our final answer, when it comes to the variation equation, k will always be replaced with a number, and y and x will remain our variables. Now, when it says varies directly, that's k times. Keep that in mind. And also, if you remember from slope-intercept form of equations of lines, y equals mx plus b, the slope was in front of the x. K is in front of the x. So k, in that sense, can also represent the slope. And we may use that to do this example. We'll do it verbally. To do this example, notice, both starting at 0, 0 hours, 0 money. When you work 1 hour, you made $20. When you work 2 hours, you made $40. Now 40 is the same thing as 20 times 2. Now when you work 3 hours, you made $60. 20 is the same as 20 times 3. When you work 4 hours, you made $80. 80 is the same as 20 times 4. Now if you were to keep on going, if you were to extend this and say we worked x hours, then that would be 20 times x dollars. And so if we let x be the number of hours, y be the money, our equation would be y equals 20 times x, or 20x, where k is 20, which is our constant of variation. Just to give you an idea that it also can refer to slope, let's take these 2 points right here. We take these 2 column points, 4, 80, 3, 20. If you remember the slope equation, the difference of the y values go on top. 80 minus 60 is 20. The difference of the corresponding x values goes on the bottom. 4 minus 3 is 1. 20 over 1 leaves us with 20. So that's kind of a way to think of it in terms of slope. Now this next example is more like what you should expect to see when it comes to variation problems. Now the next couple of examples will be direct variation. It says, suppose y varies directly as x. Stop right there. As soon as you see that, we want to write down the equation being represented. Y equals kx, or k times x. Now let's show you the problem. If y is 24 when x is 6, stop right there. Let's take those values and substitute them in. This is all substitution. 24 equals k times x, x is 6. It says find y when x is 12. What that means is we want to find y when x is 12. So we take what we know, or what's given, I should say. X is 12. We can't find y until we know what k is. Well, what this does, the reason for these first 2 numbers that were given, it's going to help us find k. Now I'm going to throw in this extra step even though it's not needed, but let's do it anyway. K times 6 is 6k, and to find k, all we got to do is divide by 6. And 24 divided by 6 is 4. What that means is that this equation becomes y equals 4x. And so instead of having this k here, we know what k is. K equals 4. And that's what you multiply to find the value of y when x is 12. 48. Now let's do another example, and I'm going to leave out a step possibly. Now this one is slightly different because the variables are different, and there's a little bit more to it. This one says, suppose x varies directly as a square of t. Stop right there. X varies directly. This one is x equals. Just because it has an x doesn't mean x always goes there. This was y varies directly, y equals. X varies directly, x equals as a square of t. So as soon as I see that word varies, I know I gotta have a constant. As soon as I see directly, I know it's multiplication. Always. Square root of t, what that means is t squared. Now, here's what we're going to do. We're going to take the first information which says if x is 40 when t is 2, we're going to substitute those in to the corresponding values. X is 40 when t is 2. Do not forget that square. A lot of mistakes happen because of that. You get 40 equals k times 4, because 2 squared is 4. I'm going to go over here. K times 4 is 4k, and we're going to solve that for k by dividing by 4. So we now have k equals 10. So this equation now becomes x equals, instead of k, we know k is 10 t squared. I'll try everything out because a lot of people leave out that exponent when they shouldn't. And now we can answer the real question, find x when t is 7. So if t is 7, I'm going to substitute it. I always use parentheses when I substitute. Do the order of operations. 7 squared is 49. Then multiply by 10. And we get our final answer of 490. Now the next concept we're going to deal with is inverse variation. Direct variation was k times. Inverse variation is k divided by. What that means is as x goes up, y goes down, or vice versa. As one goes up or goes down, the other one goes up. I guess you could correspond it to this. The more kids you have, the less sleep you get. Something like that. Now let's just do the typical problem you may see. Suppose that y varies inversely as x. Stop right there. Y varies inversely, which means I gotta have that k. Inversely means it's divided by x. Got that? Varies inversely is k divided by. Varies directly is k times. So if y is 4, when x is 3, we're doing this step so we can find k. Now, anytime you're trying to get the k by itself and it involves a fraction, the easiest way to explain it, there's all kinds of ways. There's several ways. But we want to get the k by itself, which means we need to get rid of the 3 being divided, so we're going to use multiplication. And watch you do to one side, or we're going to do to the other. These 3's cancel out, at least k equals 12. You also could put the 4 over 1 across multiplied. It's however you want to approach it. And there's still other ways, but that's the two main ways. So you end up with y equals 12 over x. That's what our equation becomes. Now what we have just done, we answered two questions. It says find the constant of variation. That's what the k is, the constant of variation. Then this should have been find the inverse variation equation. So the inverse variation equation is this equation right here, y equals 12 over x. Now this wording is just breaking up the actual parts to find the real answer. The real question is to find y when x is 12. So all that means to do is everywhere you have an x, you're going to replace it with 2. And then do the work. 12 divided by 2 is 6. Now let's do this one. If suppose y varies inversely as x. Once again, y varies inversely. I see that word varies, I need a k. Inversely means divided by, and then we have the x. If y is 11, when x is 6, this is what we're going to solve in order to get k by itself, or to find k. So we're going to multiply to eliminate the fraction. And we get k equals 66. So our equation becomes y equals 66 over x. And now we can find y when x is 22. And 66 divided by 22 is 3. Now this next example, the reason why I chose this one is so you can see that they're not always going to be y's, x's, t's. They could be something totally opposite or totally different. Suppose y varies inversely as v. As soon as I see that varies inversely, I know it's k divided by. So w varies inversely as v. That's your equation we're going to use. Let's substitute the numbers in. W is 50 and v is 10. So what we're going to do, once again, eliminate the fraction by multiplying by 10, and we get k equals 500. The equation becomes y equals 500 over v. Now it says find w when v is 100. So I'm going to replace the v with 100, and we're going to divide it out. 100 goes into 500, 500 or 5 times, and that's the answer.